Galileo, the first person to point a telescope skyward and made major new discoveries. He was able to make out mountains and craters on the moon, rings of Saturn, sunspots, four of the Jupiter moons. All he made possible through the telescope. 400 years after Galileo, now a new telescope that is more powerful than anything that's ever been sent into space, looking at the same of the furthest and oldest object yet. But before exploring this powerful telescope, let us see its predecessor, the Hubble Space Telescope.
Liftoff of the Space Shuttle Discovery with the Hubble Space Telescope, our window on the...
This space telescope was launched in April 1990 into the lower Earth orbit, which is 570 kilometers from Earth. Hubble was the first telescope designed to be serviced in space. It has been serviced by humans 5 times. Its 5 main instruments observe the ultraviolet and visible regions of the electromagnetic spectrum. It has recorded some of the most detailed visible light images, allowing a deep view into the space. Many Hubble observations have led to the breakthrough into astrophysics, such as determining the rate of expansion of the universe, galaxies, nebula, and star clusters have been seen like never before. After 30 years in making, now comes the successor of Hubble, the James Webb Space Telescope, which is successfully launched into space on December 25, 2021.
Decollage liftoff from a tropical rainforest to the edge of time itself. James Webb begins a voyage back to the birth of the universe.
This powerful telescope is looking at some of the farthest and oldest objects, and it can see back to the beginning of the universe. Let us begin with an example. The light from the sun takes 8 minutes to reach the Earth, so we are seeing the sun as it was 8 minutes ago. After the Big Bang, the galaxies started to form and emit light. So all the way to 30.5 billion years into the past, all the way to our cosmic backyard of the solar system, and everything in space and time in between. As it like a time machine, we are looking back into the past. The problem with Hubble is that Hubble is actually quite wrong. Hubble is in lower Earth orbit and it's about the same temperature as the Earth, and that means it's actually emitting in the infrared. So in that case, it's difficult to detect faint infrared light from very far away because it's swamped by light coming from the telescope itself. So the James Webb Telescope has to be placed far away from the Earth's warm atmosphere, as it has to be cold, that is minus 233 degrees Celsius cold. In order to achieve that, it has to be protected by the layer of sun shield, and the telescope sits behind that sun shield. It is placed at L2 Lagrange point, which is 1.5 million kilometers away from the Earth. But the gravity is stable, consumes less fuel, and it can stay in the line with the Earth as it orbits the sun. In this location, the telescope's main instrument can cool to near absolute zero temperatures and receive the infrared light. Then they can take the light and produce images or analyze the light to learn what materials are present. This is known as spectroscopy, and it's a major feature of JWST's science instruments. The Hubble Space Telescope operates primarily in the optical, so the wavelength that we can see. But as we look at the most distant galaxies in the universe is expanding, those galaxies are in essence receding from us at a faster speed. And that means that their light is shifted from the visible into the near infrared region. So in fact, when we want to see the very most distant galaxies, Hubble can't see them. It's unable to see at right wavelength as it is covered with dust and gases. So we need a big telescope operating in the infrared that can penetrate through the dust and gas, just like James Webb Telescope, in order to see those first galaxies. After a successful launch into space, 50 successful deployment, 1.5 million kilometers traveled from Earth, months of cooling to near absolute zero and calibration, The James Webb Telescope has finally delivered full-colored science-quality images. NASA released its first 5 images on July 11 and 12.
Put together, it's a new window into the history of our universe. And today we're going to get a glimpse of the first light to shine through that window. Light from other worlds, orbiting stars, far beyond our own. It's astounding to me when I read this.
The iconic James Webb Telescope beat all expectations with its first image. This first image of a galaxy cluster SMAC 0723 as it looked 4.6 billion years ago. This is Webb's first deep field image and is the sharpest infrared image of the distant universe so far. The prominent arc of the light in the image are due to gravitational lensing. Massive structures such as galaxy cluster bend the light from background objects. These clusters act as a normal magnifying glass and are known as gravitational lensing. Let us view the Webb's other 4 images. Let us compare the image taken by both the telescopes. We have already seen about the details of SMAC 0723. It is a massive foreground galaxy clusters. Next comes the Southern Ring Nebula or 8-burst nebula is a planetary nebula, an expanding cloud of gas surrounding by a dying star located 2000 light-years away from Earth. Stephen's Quintet, about 290 million light-year away, it is located in constellation Pegasus. It is the first compact galaxy group where the 4 out of 5 galaxies are locked in a cosmic dance. Out of 5 images taken by James Webb, this is the most beautiful one, the Carnot Nebula, the largest and brightest nebula located approximately 7600 light-years away from the southern constellation. Next comes the exoplanet WASP 96b. JWST also revealed the spectrum of this exoplanet. It has a mass less than that of a Jupiter. Webb has captured the signature of water and evidence of clouds and haze in its atmosphere. This telescope is designed to last at least 5.5 years with a goal of 10 years. But the scientists believe that this telescope significantly will have longer lifespan than the planned one. In the upcoming years, the James Webb will reveal more of the secrets that are hidden in the universe. Let us wait to watch those.